Assalamu alaikum, guys. Hope you are doing hope all of you are fine and you're staying in your homes. In last lecture, we had started with decimation frequency FFT algorithm. Basically, we had started by dividing the x of k into two summations with limits from 0 to n by 2 minus 1, and then we had divided them into odd and even parts, that's x of 2k and x of 2k plus 1. And this diagram depicts this diagram here. This depicts the depicts what we had done in the previous lecture. Now in this lecture, what we need to do, we need to break down, we're taking an example of n is equal to 8. Now we need to break down this 4-point DFT into smaller DFTs, that is the 4-point DFTs here and here. They need to be broken down, so we'll continue on that. Now so what we need to do now, we need to find four-point DFT, right? Okay. So basically what we need to do, what we will be doing, we will be dividing g1 of n and g2 of n. g1 of n is our even sequence and g2 of n is our odd sequence into even and odd parts. Okay. So I'll go to the next page. So let me first break down g1 of n, fine, and I guess g1 of n was given as x of n plus x of n plus n by 2, fine. So I will break it down into two parts, even and odd, fine. So let me assume p11n and p12n are even and odd parts of g1n, fine. So now we know in case of g1 of n, the number of samples is, since we are assuming, we have assumed as in previous class, n is equivalent to 8. So if n is equivalent to 8, this was as far as x of n is concerned. So in case of g1 of n and g2 of n, which are equivalent subdivisions of x of n, therefore g1 of n has 4 samples and g2 of n has 4 samples. Now what we are doing here is we are dividing g1 of n into two subdivisions, that's p11 of n and p12 of n. Again, these are equivalent subdivisions of g1 of n. So this means p1 of n and p12 of n, sorry, p11 of n and p12 of n, they will be having 2 and 2 samples. So n in case of p11 of n will be from 0 to 1, and in case of p1 of 2 n will be from 0 to 1, fine. So this is, so I can write n number of samples in subdivisions of g1 of n will be equivalent to g. Fine. So now what I will be doing is that I will be deducing the equations for p11 of n and p12 of n using equations g1 of n and g2 of n. Now p11 of n, it's an even sequence, so this is similar to g1 of n, so I will write it down. So p11 of n will be equivalent to, so if we notice this equation, that is for the even sequence of x of n, subdivision of x of n, that is g1 of n is equivalent to x of n. right? So and G1 of n is a subdivision of X of n. Now P11 of n is a subdivision of G1 of n. So I will write here G1 of n plus similarly G1 of n plus, now here if we notice it is n by 2, that's number of samples in X of n divided by 2. So now P1, in case of P11 of n, it will be number of samples in G1 of n divided by 2. So number of samples in G1 of n is n by 2. So I will write n by 2 divided by 2. Fine. So this is equivalent to G1 of n plus G1 of n plus n by 4. Fine. So now let me come to P12 of n. So also we know that I guess G2 of n is equivalent to X of n minus X of n plus n by 2 whole multiplied by Wn of n. What is G2 of n? This is an odd sequence, right? So what is P1 of 2 of n? It's also an odd sequence, right? So we will try to derive P11 of 2 of P12 of n using G2 of n. So let's go to the next page. So I can write P12 of n as, instead of X of n as in case of G2n, I will write this P12 of n is derived from G1 of n. So I will write G1 of n minus G n plus n by 2 whole divided by 2 into W n by 2. Right. So this if we try to compare them, in G2 of n, this is an odd sequence subdivision of X of n. So here X of n is written, P12 of n is an odd sequence subdivision of G1 of n. So G1 of n is written here minus as in here X of n plus n by 2 is written. So here I will write minus G n plus number of samples in G1 of n divided by 2. That is, number of samples in G1 of n is n by 2 divided by 2 into whole multiplied by in case of G2 of n, we had odd sequence, we had Wn raised to power n. So number of samples here, n value of n was taken as the number of samples in X of n. So here value of n will be taken as number of samples in G1 of n, that is n by 2. Fine. So we have got the equation for P11n and P12n, and the range of n here will be 0 to 1. Fine. So let me substitute now. In case of P11 of n, we had that was equivalent to G1 of n plus G1 of n plus n by 4. Fine. So let me substitute n is equal to 0 and 1. Now for n is equal to 0, I will get P11 of 0 equivalent to G1 of 0 plus G1 of 0 plus n by 4. N we have assumed it is 8, so it will be 8 by 4, that will be 2. Fine. So that will be equivalent to G1 of 0 plus G1 of 2. Right. Now if n is equal to 1, then P11 of 1 will be equivalent to G1 of 0, sorry, mistake here, it will be, we have to substitute n equivalent to 1. So it will be G11 of 1, here I will substitute 1, and then it will be G1 of 1 plus n by 4, that is 8 by 4, that is 2. So g11 of 1 plus g1 of 1 plus n by 2, that is 2. So I will get g1 of 1 plus g1 of